Hello and welcome to this energy investment analysis lesson on cash flow basics. So what we're going to cover in this video is what is cash flow, what is the convention for cash flow, and how should you determine the study period for your cash flow, as well as look at some examples. So let's look at a little overview. Cash flows are an easy way to visualize all costs, positive and negative, for a given project over a given time period. So really what you're trying to capture is all the different costs or savings or benefits to your potential project that you're implementing. If you have several different alternatives, for example, buying a different car or several different solar power options, a cash flow must be made for each different alternative. So the convention is a big deal for cash flow. In this course, we're going to say that money going into your pocket is positive, and then money leaving your pocket is negative. And we'll show a few examples to get you thinking that way. So let's talk about would the following examples be positive or negative in a cash flow diagram. So if you're buying a CFL, that's money leaving your pocket, so that would be negative. If you're mailing in a rebate for a purchase, you're going to be getting money back, so that's positive. If you're buying an inverter for a solar power system, you're buying something, cash is leaving your pocket, so it's negative. If you're getting a tax subsidy from buying a solar power system, that's cash going into your pocket, so that's positive. Now let's talk about the study period. The study period is something that all cash flow diagrams should have in a good life cycle cost analysis. And this is directly from the NIST life cycle costing manual that the study period for an LCCA is the time over which the costs and benefits related to a capital investment decision are of interest to the investor. So as you can see, it leaves it relatively broad. And some rules of thumb to figure this out, the study period is never going to be greater than 25 years according to this life cycle costing manual. It's going to be equal to the longest life of your equipment, so the piece of equipment that has the longest life. And if an investor has a shorter time period of concern, so a good example here is if you have a leased building and you're only leasing the building for 10 years, you would want to make your study period for 10 years. Then you're going to make a shorter study period. So let's just think about this for a second. The other thing we want to deal with in our cash flow is if we have a relatively short study period and we have equipment that lasts longer. So let's think about solar panels with a 20-year lifetime that cost $50,000. So what would you think is the least amount of money you would accept for the panels after 5 years, 10 years, and 20 years? So just come up with a number on your own for each of these and think about how you might go about calculating this. Okay. So now we're going to show you how we're going to calculate in this course. And this is going to be called something called a residual. And again, this definition is right from the book, is that the residual value of a system is its remaining value at the end of the study period. So there are many ways to calculate this, but we are going to calculate the residual by linearly prorating its initial cost, which sounds utterly ridiculous, but you'll see what I'm talking about with a few examples. So let's look at this formula and example. The residual is the useful equipment life left at the end of the study period divided by the expected equipment lifetime times the initial cost. So let's see how to apply this. So if we look at our solar power example, that we buy these solar panels in year 0 for $50,000 and they are expected to last 20 years. What would be the residual if my study period were 10 years or 15 years? So let's look at the 10-year study period. So the first is, the numerator here is the useful equipment life left at the end of the study period. Well, that's the total equipment life, 20 years, minus how long it's been used for the study period, for a 10-year study period, it's been used for 10 years, divided by the expected equipment lifetime, which is 20 years. So, and then we multiply by the initial cost, which is $50,000, so it's $25,000. So this makes sense because we've used the equipment for half of its expected lifetime, so it's half the cost is the residual. If we look for a 15-year study period, we do the same exact thing, except now instead of the 10 years we've used the equipment, we've used it for 15 years. So basically, we only have 1/4 of the benefit left out of this equipment, or $12,500. So if you think about this, the residual, the way we're going to calculate it is very simplified. You've probably heard about if you drive a car off a lot, it loses a lot of value the day you drive it off the lot. So there definitely are different ways to calculate the residual, but we're going to make this simplifying assumption. So let's just take a look at this residual graphically. So if we have on the x-axis here basically the study period amount. So in our example, if we had a study period of 10 years, the residual would be $25,000, or 15 years would be $12,500. So this is just to show you that why it's called linear prorating is that this is a straight line. The top of the bars make a straight line. And of course, if you had a 20-year study period, then the residual would be nothing because you have no useful lifetime left in that equipment. So let's look at putting this all together in a cash flow diagram. So this is a cash flow diagram of 3 different light bulbs: an incandescent, which is INC, a compact fluorescent, which is CFL, and a light emitting diode, which is LED. And what you can see is the first year, the year 0 in the cash flow diagram is when we buy the light bulb. So the incandescent has a relatively low cost to buy. The CFL has a middle cost to buy, and the LED is really expensive to purchase. And then every other year, you can see year 1, year 2, year 3. The incandescent's expensive to run, the CFL is less expensive, and the LED is less expensive. Then something happens in this year. For some reason, the CFL bar goes even lower, and this is because the CFL bulb burns out at this year, and we have to replace it. And then again, it burns out this year, we have to replace it. And then it burns out again this year, we have to replace it. It turns out in this example, the incandescent bulb burns out every year, so we're replacing this every year, and that's why the bars stay constant. And then if we look at the very end here, what happens is that our LED actually never had to be replaced, and we even has a good amount of useful life left. And so the residual happens at this very last year. So the residual of the LED bulb makes this go into the positive. So it looks like this is cash going into our pocket because you can think about it, we're going to sell that useful LED at the end of the study period. And then we do the same thing for the CFL, but the CFL doesn't have much useful lifetime left, so it just lowers the bar from here to here. So that's an example of cash flow. Thanks for watching.